Yesterday we talked a little bit about neutralization, where you react an Arrhenius acid with an Arrhenius base. You always get a salt and water, and we just practiced that in the do now. And what we want to talk about today is a process known as titration. And you've seen the burettes in the laboratory this year. It's something we do quite a bit of in AP, and you get an introduction to it here. Titration is an experimental way to determine primarily the concentration of a substance, and in our case, the concentration of an acid or a base. So in the lab next week, you will be given a known concentration of sodium hydroxide. You will be given about 10 to 25 mils of an acid, and you will be trying to determine the concentration of the acid. And you can do this by titration. What you do in titration, and I'm not going to pull a burette out. We'll get one. I'll go get one. So you have the burettes, which are long, skinny tubes, and they're graduated. So they have lines on them. And so you will know the volume of solution that you are adding to another solution. So you're going to gradually add one reactant from the burette. This is your burette. This is known as your titrant. So what goes in the burette is known as the titrant, and what you're analyzing will typically be in an Erlenmeyer flask, and that's called the analyte. So what goes in the burette is the titrant, and the other reactant will be the analyte, and you will add one substance to the other substance very slowly until a color change occurs, and you're looking for the slightest color change, and we'll illustrate that in much more detail when we do the lab on Monday or Tuesday. One other critical piece of information is when all of the acid and base have reacted in equimolar amounts, we say that they are stoichiometrically equivalent. The millimoles of acid and base will be equivalent. They may not actually be equal to one another depending on the stoichiometric ratios, but they'll be stoichiometrically equivalent. And this is known as the equivalence point, when millimoles of acid and base are stoichiometrically equivalent. You'll be able to see this point because you will get a color change, and that color change signifies the end point. So it says the end point is what you actually see because you'll get a change in color. For example, we'll be using phenolphthalein, and phenolphthalein is colorless in acid but turns pink in base. So initially you'll put your phenolphthalein in acid, it will be colorless, and then you will add base until you get the slightest pink color. When you get that slightest pink color that remains, that's your end point. And at that point, you've reached the equivalence point where millimoles of acid and base are equivalent. I'll explain the millimole concept to you in just a minute. So for example, if you have a sample of hydrochloric acid in an Erlenmeyer flask and you add sodium hydroxide to it, the sodium hydroxide will be in the burette. If it's in the burette, is it the titrant or the analyte? That's going to be the titrant. So what comes through the burette is the titrant. So sodium hydroxide might be the titrant, and hydrochloric acid the analyte if the hydrochloric acid is put in the flask. When you've reached the equivalence point, the millimoles of these two substances will be equivalent. Now, if you have a 1-to-1 mole ratio, they'll also be equal. I'm not going to give you a 1-to-1 mole ratio in the lab because that would be too easy and you're very smart, so you need a better challenge. The solution will turn and remain the faintest color of pink. That color change you see is the end point. And it's important to understand the difference between the equivalence point and the end point. So before you reach the equivalence point, you have more acid than base, so the solution's colorless. When the equivalence point is reached, the millimoles of acid and base are stoichiometrically equivalent. You're going to essentially have the faintest color of pink. And then once you go past that point, you'll have more base than acid, and you'll have a darker pink. And we'll illustrate this with the lab in a couple of days, or I could actually show you in a little bit. What we want to feel comfortable with today before doing the lab is how to calculate concentration or volume of an acid or a base. Now in the lab you're more apt to calculate concentration, and that's what I also did on your test. So we'll focus on that initially, but I'll also show you how to determine the volume. There are a couple of pieces of information that you need to recall from previous lessons to be successful here, and we'll review those concepts. When you want to calculate the concentration or volume of an acid or a base, the first thing you're going to do is write the balanced chemical equation. And that's why we went over neutralization reactions yesterday. I wanted you to master that concept first before putting it with additional ones. You will also record information about each substance, and I'll show you how I do that. You're then going to calculate the number of moles or millimoles of acid or base. If they give you a volume in mils, and they probably will, it really is easier to use millimoles. I'll show you that in a minute. So you're going to calculate moles of one of the substances, and it'll be the one that you have the most information on. You'll know both the concentration and the volume of one of the substances, so you can calculate millimoles. So you will recall is that good in the back? Yes, yes? Okay. We talked about this the other day as well, and it's in the solution chapter. Capital M represents what unit of concentration? Molarity. And molarity is moles of solute over the total volume of solution in liters. The solution piece is going to be a little tricky here. We'll point it out clearly when we get there. If I wanted to solve for moles, what would that be equal to? Molarity times the total volume. So in the case of an acid, the moles of the acid are going to be equal to the molarity of the acid times the volume of the acid. Now we did this for moles per liter because that's what we learned molarity is way back in our solution chapter. However, we could do molarity as millimoles, let's say, of acid over the volume of acid in mils. The millis will cancel, and you'll essentially have moles per liter. But when you're given a volume in mils, it's much easier to use millimoles because you don't have to start sliding decimals. So millimoles of acid will be equal to the molarity of the acid times the volume of the acid. So this would be for the acid. Or if you were dealing with the base, it'd be the same type of setup. So millimoles of base would be equal to the molarity of the base times the volume of the base in mils, okay? So if you're given mils, sometimes it's easier to solve in millimoles, and I'll show you what I mean in just a minute. Once you calculate the millimoles of the acid or the base, whatever you know both the molarity and the volume of, you can use stoichiometry to go from acid to base, because at the equivalence point, the millimoles of acid and base will be stoichiometrically equivalent, and we'll point out each step as we solve a few problems. And then finally, we can calculate the concentration or the volume, because we know concentration is millimoles over volume, or if we were asked to solve volume, we could interchange these two variables. So the volume of the acid would be the millimoles of the acid over the molarity of the acid, and I'll show you how to do all of those things as we solve the first problem together. Questions here?
The only difference between calculating normal molarity and moles is that in this case you're putting volume in terms of milliliters rather than in terms of liters. There's nothing significantly different other than you're calculating in terms of milliliters.
Primarily, yes. So in regard to your question, typically molarity, moles of solute per volume of solution in liters.
Right.
However, this formula here, which is millimoles over the volume in mils, is the same one as this, because essentially you could just get the millis to cancel, and then you'd have moles per liter, correct?
Mm-hmm.
So they are the same. I'm saying go after millimoles if they give the volume in mils, because you won't have to do any type of conversion. So if they give you mils of the acid, just multiply it by the molarity. That gives you millimoles, not moles. But they look identical, and the only thing that's different is you have milli here and here.
Okay.
All right?
Mm-hmm.
Okay, so in the example provided, it says in a titration of a sample of 20 mils of hydrochloric acid, is that the concentration or the volume? So here's your volume of acid. 30 mils of 0.2 molar sodium hydroxide is required for neutralization. At the neutralization point, the millimoles of acid and base will be stoichiometrically equivalent. We want to calculate the concentration of the acid, and we will do so using the steps on the screen, and we'll point them out as we go. So Zach, what's the first step? You got to write all the stuff out. You got to write a balanced equation. So what's our acid? Hydrochloric acid is HCl. And what's our base? Sodium hydroxide. And this was the reaction we saw at the very beginning, a double replacement reaction. An Arrhenius acid with an Arrhenius base always makes salt and water. Good. And this one's very, very easy. It's all balanced for you. Okay. The other part of step 1, I'll put an A here for step A, actually, is what it says in your notes, is I like to write down the information that I'm given. So the volume of the acid is 20 mils. The volume of the base is 30 mils. And the concentration of the base is 0.200 molar. So that's step A. I write the balanced equation, I record the information. What I'm looking for then is the concentration of the acid. Step B says calculate the number of moles or millimoles of acid or base, and you're going to do it for the one you know both the concentration and volume. So we're going to get millimoles of what? The base. How come? You have a concentration and a volume. So you're going to multiply the molarity times the volume, all for the base. You've got 0.200 molar. I'm going to write that out as millimoles over milliliters. And you're going to multiply that by 30 mils. And you'll see that the mils will cancel here. Okay? So we calculated the millimoles of the base first because we were given both the concentration and the volume. And we've got, watch your sig figs here, 6.00 millimoles of sodium hydroxide. So this is step B. Calculate the millimoles of the substance. You know both the concentration and the volume. Bless you. Step C says calculate the number of moles or millimoles of the other substance using stoichiometry. So, from the balanced chemical equation now, we can go from millimoles of base to millimoles of the acid. This is a 1-to-1 mole ratio. You can just use millimoles. And that will be 6 millimoles of HCl. So that's step C. That's your stoichiometry from the balanced chemical equations. The ones came from where? Coefficients. You got it. Good. And then finally, we're going to calculate the concentration of hydrochloric acid. That's the molarity. We have 6 millimoles of the acid. And the volume of the acid, don't add the volumes together here, that's going to be a problem. Stay acid, stay base. So the volume of the acid is 20 mils. So you're going to do 6 divided by 20, and you've got a concentration of hydrochloric acid of 0.3 molar. And that is your final answer. All right, a 4-step process. You write your balanced equation. You put the information under each substance. Excuse me? Yes. You write the information under each substance. Anybody else want to borrow a calculator? Calculate the millimoles of the substance that you know the most about. Stoichiometrically calculate millimoles of the other substance, and then you'll divide by the volume to get the molarity. If they ask you for volume, you'll divide by the molarity, and I'll show you how to do that in the next problem. Questions here?
You got Sheila a birthday card?
Questions here? Okay, this is very complicated. I've really tried to simplify it in baby steps. If you work through the steps, I think you'll get very good at this. And one thing I have tried to impress upon you all year, you must practice. You don't know how to do it yet. There's a lot of ways to trip this up. There are ways to just make it a little trickier. You don't always have a 1-to-1 mole ratio. Did you write the chemical formulas correctly? Be careful, and the more practice you do, the better you're going to do on this question on your test. This is not on your quiz, on your test. You've got to be comfortable with this type of analysis, okay? And again, you'll get more of the conceptual piece and the experimental piece when we do the laboratory, which is very fun. I can show you a little video on titration so you can pull it all together. I just want to focus on the math piece first so you know how to do it. All right, in the second problem, it says in a titration of a sample of 1.5 molar calcium hydroxide, 25 mils of 0.8 molar hydrobromic acid is required for neutralization. Calculate the volume of the base at the equivalence point. Okay, let's take a look here. First of all, let's pick out the relevant information. What's the concentration of base? 1.50 molar base. And we've got a volume and concentration of hydrobromic acid. And we want to calculate the volume of base at the equivalence point. So that's the relevant information. And now I need you to try and talk me through as we go. Okay, on number 2, what do we do? Write the chemical formulas. I usually do acid, then base. It doesn't really matter. I just always do it that way because it's easier to keep track of. So how do we write the chemical formula for hydrobromic acid? HBr. Good. Binary or ternary? Binary because it's comprised of 2 elements. Strong or weak acid? That one's strong. All right, from group 17, hydrobromic, hydrochloric, hydroiodic acids are all strong. What's our base? Calcium hydroxide. How do we write the chemical formula of that one? Good. With parentheses. Don't forget those parentheses. That's why we re-emphasize that point. That'll make a mess. You won't get your equation to balance. What are the products of this reaction? Calcium bromide.
Hi, pardon the interruption. Please release all ACE Global prospective students taking their exam for their lunch at this time.
Good luck, Christian. Christian, we're filming, but you've gotten the crux of it, and I'll help you with it tomorrow, okay? Okay. What's missing on my calcium bromide? The 2. Hi, Maria. Welcome back. Say hi. You're on camera. Hi. And the other product is H2O. Good. So this is a neutralization reaction of an acid and a base, both of which are Arrhenius, generating the salt and water. So in step A, we always write the equation.
Does it have to go acid first then?
It doesn't, but I just always do it the same way because then I don't make a mistake. So I highly recommend it. It works well for me. But if you want to go base acid, whatever makes you happy. Either way is correct. All right. We also want to write down the pertinent information
Balance it.
Oh, I didn't balance it. All right, what do I have to do? We got 2 of those, so we need a. And now we have a total of 4 H's on the left, so we need a. Good job. If you don't balance it, your stoichiometry is going to be very messy. The concentration of the base is 1.50 molar. The concentration of the acid is 0.800 molar. What's the volume of the acid? 25 mils. Good. That's step A. Do I'll letter them, yeah? What's step B? Now you guys don't have to letter them. Moles of what? Why? Because you have both the concentration and the volume. So, Grant, why are we going to do millimoles?
We're going to do millimoles because we already have the volume in milliliters.
You are spot on. So, millimoles of the acid is equal to the molarity times the volume of the acid. And that's going to be 20 millimoles of acid. Now what? Convert it to what? To the base. At the equivalence point, the acid and base are stoichiometrically equivalent. So here comes my stoichiometry part. What do I do? Mole ratio? Okay. So why would I put millimoles of hydrobromic acid on the bottom? To get them to cancel. And what goes in front of that millimole? 2. Okay. What goes on top?
1.
1 what?
1 millimoles.
Of what?
Calcium hydroxide.
Good job. So that's equal to 10. Okay, this piece is slightly different, but it's really easy. You're going to be good at it. We want to know the volume of the base. Okay, we know molarity is millimoles over the volume in milliliters. So again, just like we've talked about in previous units, you can interchange a numerator on one side of the equation with a denominator on the other side of the equation. So the volume in mils is just millimoles over molarity. So, do we have millimoles of base? Yeah, right there. What was the molarity of the base? 1.5 molar, right? Let's go back up to the top here. here's our base. We were trying to figure out the volume. We were given the concentration. Make sure you use the correct piece at the end. Otherwise, you're going to have a little mistake. There's always partial credit on these types of problems. And you've got, wow, a little volume. 6.67 mils of base. Okay? Now your lab's going to look slightly different because at first glance it's going to appear that I only give you the concentration of the base and the volume of the acid. But through the titration, you'll know how much base you added by reading the burette. We'll point that out in great detail when we do the lab. And then you'll be calculating the concentration of the sulfuric acid. I made it the other day, and then we'll get a really good idea of how good of a job you've done, because I know what the concentration of the acid is, and we'll see if your calculation is close to what the theoretical concentration should be. Questions here? Do you want to do 3 together, or you want to try it? Try. I'm going to help you with the equation because it's a little unusual, but it's something that you would use in your house, so I thought it was a good example to use. Number 3 says, in a titration of a sample of vinegar, vinegar happens to be 5% acetic acid, 11.10 mils of 0.748 molar strontium hydroxide is required to neutralize a 10 ml sample of vinegar. And as I said, vinegar is 5% acetic acid. We want to calculate the concentration of acetic acid, and I did formula write it for you there, but you should be able to do that. And then we're going to link this back to stoichiometry and calculate the theoretical yield of the salt. So let's take a look at how we're going to set this one up, and then we'll have some practice for you to do. What is my acid? Acetic acid. And remember, the ionizable proton off a Cu group is that H attached to the Cu group, if you will, part of the Cu group, I should say. And we're going to react it with strontium hydroxide. This is a little unusual with the insides and the outsides, so I'll help you with this one. I wouldn't give this on a test, but you get strontium acetate. Oops, no H there. I can't believe I just did that. That's so silly. I just kept writing. The pen got away from me. Gotcha. Strontium acetate and water. All right, that's your equation. Let's pull out the information and then we'll give it a try. So what is the volume of the acetic acid? The vinegar, look at the vinegar. 10 mils, good. And we want to know the concentration. The volume of the strontium hydroxide is 11.10 mils. And the concentration is 0.748 molar. Okay? And we're going to give this one a try. At the end of the lesson, you should have a much better understanding of titration. We'll talk more about its uses next time, how to name acids and bases, and it all feeds into the learning goal for this particular chapter. And as I mentioned, you guys are a little bit ahead. We delayed your quiz because it was in everybody's best interest, but your quiz goes up to the point of naming. Naming's not on there, either is this, all right? We'll try and do this problem, and we'll see if you were successful. And then after your quiz tomorrow, you'll have a lot of problem-solving time, but I'll review theoretical yield with you because we haven't seen it since the beginning of the third 9 weeks.